Okay, I hope every one of you can see this slide. So we're going to start on the instrumentation for monitoring and controlling. So looking to this title on the subtopic chapter 3, so I think that it's not implement on the chapter 3 only. It can be also being carried out on chapter 1, chapter 2, as well in chapter 4. Because the purpose we are doing the monitoring and controlling measurements to tackle any future problems. And then what's exactly our problem? Of course, in this chapter 3, I am focusing few selected cases related to geotechnical failures, such as settlement, differential settlement, bearing capacity failure, slope failure, sliding failure, overturning failure. So these are some sliding, overturning, bearing capacity failure can be observed from the returning walls, constructions or applications. And then settlement can be also observed due to the loadings applications from the embankment. And then if you have some kinds of the um, building constructed on any soft soil, and then you want to predict the settlement in terms of the vertical displacement, so you can see the effect of the soil movement. So how do we do that? And then how do we control, or how do we get the informations regarding to the output or what we are looking for? So the instrumentations and monitoring can be conducted in the preliminary of our stages of constructions, as well as also during the constructions, and also on the post-construction. Post-constructions here referring to the for the long-term period of stability. For example, if you are designing for a man-made or cut slope, you are proposing some kinds of the slope geometry design, and then the slope has been constructed on site. You want to see either there is a slope movement in the future or not, so we can install a tool or equipment which can help you give some informations on what we have observed from the site. It means that is there any movement of the soil, and then you can also see the point of the slip failure. And then if you have some applications on the foundation, such as bearing capacity failure, you want to some failures on the foundations of bearing or the pile foundation cannot be seen easily because the structures has been built below the ground surface. So the other way is that using the probe or some kinds of the tool or techniques that can give you on-site data regarding to what the output or what's the data you are looking for. And then who has this problem? Since we are focusing on the chapter 3, of course, we want to see on any geotechnical engineering applications or geotechnical infrastructure, such as foundations deep, or we have the shallow foundations, or you want to construct slope, or you want to have some kinds of any road constructions, and then you want to construct uh, what we call it here, or anything that you can see there is chances for failure occur. So why should this problem be solved? Because we want to prevent or avoid any future excessive failure, which can cause to the loss in life, and also can give some impact on the economy, money losses, and anything that regarding to the public usage, such as if you have some kinds of the road damage, this will be affected to the road passengers or any users on the facility. So we want to prevent that failure getting worsened, which consume a lot of money to be repaired. So in terms of the maintenance or monitoring can be done frequently or periodically, so we can save in terms of the budget. So how will I know this problem has been solved? So by using the mitigation techniques such as instrumentation for controlling and monitoring during the construction activities. So at the end of this slide, I try to give and share some video which may give you some idea how this controlling, instrumentation, monitoring can be given some informations for future design or future analysis related to the constructions site. Okay, what is exactly geotechnical instrumentations and monitoring? So the instrumentation and monitoring technology are increasingly used to monitor structures, processes, and infrastructure under construction and during the operational phase in order to verify design and planning and detect events in order to reduce risks. So it is used for measuring displacement of adjacent buildings, utilities, and excavation support system in urban and suburban environments, or slope failures and dam construction in rural or semi-suburban areas. So the instrumentations is talking morely on the equipment. What's the method you chose to use on site, which can give you a parameter design, for example, a parameter control, which can assist you in accomplishing the measurement and performance evaluation of this system. So the instrumentation, as I said, can be carried out during or before and after the construction activities. I mean that for the initially you can do some monitoring to what we call it monitoring in terms of, for example, you want to measure the water levels. So we need to collect the water level first before you can do any design. For example, you want to design shallow foundations. So you are required to calculate ultimate bearing capacity with the effect of groundwater table. How do we know that the depth or the presence of the water table at which depth? Of course, we have to use some tool or some sort of the probe or equipment that can give you informations on the groundwater level data. By using these informations, then you can propose the best design of the shallow foundation in terms of the shapes, in terms of the sizes, in terms of the material. I mean that if you remember back how you can calculate the ultimate bearing capacity of the footing, for example, these are some parameters that can be added into your analysis. And the foundations and also the bearing capacity also being affected due to the presence of groundwater table. So if you do not do or if you do not carry out any measurements on the groundwater table by simple assumptions, for example, there is no groundwater table effect to the bearing capacity failure or anything related to your design, that will bring to you a future failure for the foundations. So it is better for all of the engineers on site or site engineer and then design engineer to properly investigate the site or by doing site explorations to give you a complete set of the geotechnical data. So it's part of the measurement for the design and analysis. It also used for performance evaluations of the system. Meaning that it can be by having this some sort of equipment, methodology or techniques that you can evaluate on your design part. Is it the design is safe for the next 5 years period, or is it the design could not sustain for long period or long-term stability? So the performance evaluations also already integrated by having some sort of the on-site monitoring by what we call it here online, or we have a remote data that can be observed through the IoT, Internet of Things. So by having this IoT, you do not need go to the site just to have some evaluations on your infrastructure project. It's very easy. So the performance evaluations is very important to evaluate for the long-term stability in any infrastructure design. So what are the equipments that can be used for the monitoring and instrumentation for controlling? Some examples are inclinometers, piezometers, tilt meters, beam sensors, joint meters, crack meters, strain gauge, pressure, etc. So I hope that some of you are very familiar on this kind of instruments. Inclinometer, what's the use of inclinometer, piezometer, and then crack meters, what are the instruments we are using to measure the crack length, the crack width, and then how do we get the crack pattern, for example, and then how do we use the meter. But during these sessions, I will not showing to you the installations process for these instruments. I think that that can be some of you may need to access from the YouTube. So not to forget, when we talk about forensic engineering, there's something that you have to conduct on postmortem analysis. For example, identifying the causes and then what's the effect on this part, and then you need to understand the process involved causing to this kind of the failure, and then how do you do or how do you propose some mitigation technique, and what are the lessons learned can be taken for the record or for the future reference. So talking about this one, instrumentations, monitoring and controlling is part of it when you are reporting any case failure. So not to forget, when you try to write up on your project report, please include also, is there any instrumentations required for the mitigation or for repairing work? For example, if you remember in the early topic chapter 3, I have shown to you and presented to you a case where the building had a differential settlement. In order to prevent the differential settlement in future, they did on some mitigation work by placing some joint bar, if I'm not mistaken. So during the installations, they need to install a kind of the equipment or some sort of instrumentation tool. So it is give some kind of the idea, are you reaching to the required depth or length specified in the design. That's the reason why we need to use the instrumentations and monitoring during pre or post construction. Okay, these are some types of instrument that can be used on site. For example, total station for positioning monitoring. And then we also have inclinometers and also tilt meters. We also have piezometers, and the last one is a vibration monitors. So the vibration monitors, if you search from online, there's a lot of equipment right now on the slope stability can be observed using a radar. So the radar give you informations on the capturing slope, potential slope failure. So it gives you the informations and the chances or the stability of the slope by using the latest advanced technology in instrumentations. So something that I shown here using manually, or something can be integrate with the digital measurements. So depending on your budget, if you are working as a sales engineer in geotechnical company, you may see some latest equipments and also technologies in their lab, for example, and also they are importing all those equipments from overseas just to give or provide a good service for Malaysia. So if you take one example here, start off total station for positioning monitoring, and then you read through. It is used most often in positional monitoring, including the measurement of excavation support system and adjacent structures, settlement of fields and movement measurements of critical infrastructure. So it is manually operated or automated with the use of robotics. The laser acquire measurement functionality allows easy data collection from long-range setup to adjacent buildings, structure support or excavation system. So, rasanya semua orang dah pernah gunakan alat ni. Have you experienced using this tool or equipment? Pernah ikut tak kursus survey? Pernah tengok tak alat ni? Kita tanya Muhammad Azim. Azim ni ada ke tak ni?
Ada, madam.
Pernah guna tak alat ni dalam survey? Pernah buat tak? Ke awak yang apa? Rasanya tak kot. Masa diploma pernah tak guna alat ni? Azim?
Tak ingat.
Tak ingat? Okay, tak apa. Nanti you find out rupa dia macam mana, tinggi dia macam mana nak didikkan alat dia, apa yang dia boleh present you, what kind of the data from this positional instruments. So, kalau kita tengok positional monitoring ni, and also the measurements, and of course, selalunya we understand that this tool, dia akan bagi you what we call it a length. Panjang tu berapa kan daripada satu point building kepada point building yang seterusnya. Apa tujuan dia? Supaya kita bila construct building tu kita tak langkau daripada boundary dia lah. So this will give you some guideline lah in terms of the sizes of the building itself, and then the length of the area. So very important bila you nak mula satu pekerja ke ataupun in the road construction ataupun on the site area. So we are using this this tool or instrument at the first stage of our project. So continue with these instrument types. So I think that some example or some tool operated digitally. So it's good about automated data. It is a real-time data collection. The real-time collection meaning that what's happened now is what you can have. During the time failure, some of the people may not on the site. So when we insert or when we adopted an automated data collections that will give to you at the specific time of failure occurs, you will have the right effect on the incidents. I mean that if you have a rainy season or you have at that particular time we got a rain or we have some sort of the slope failures, and then during the time also you can see the soil displacement or soil movement, how much the soil has moved from one point to another one, and it's what we call it here is very safe in terms of the time allocation compared to you have a manual data. Similarly to the total station for positional monitoring. So we don't have so much worker to work on, just use the digital one. It can display to you the length of the adjacent building, and someone only may require one person to record the data. If compared to the if we compare with the manually, so the data can be collected by having some group members. The person will record the data, the other two persons will do the measurements. So it will time consuming in terms of the data collections. So this is similarly for total stations. So you can see that the project at the early stage where we have a site clearance and then measure the distance from one point to another point. Is it we have reached to the locations of the site boundary area? Okay, the next one on the inclinometers and tilt meters. So inclinometers and tilt meters are very common to measure the excavation or any kind of displacement. Either you have a structure or the soil deformations. So typically used cases include measuring the performance of excavation support system during excavation and construction, installation in landslide or slope failure zones, structural building monitoring for tilt and long returning walls. So when you do on the slope monitoring, for example, or embankment constructions, so inclinometer is very common is tool or equipment that can be installed on site. So the important is that we want to measure or we want to get the displacement of the data. The displacement, for example, if you are predicting for short-term stability or you are calculating for short-term stability, you can see that once you apply loading, what's exactly the deformations of the soil, for example. Is it the deformation of the soil has reached to the maximum what you have calculated earlier, or it just give you some early sign that deform has taken place. Or you also can use the inclinometer for predictions by having the data on site. I mean that if you are calculating the settlement for future settlement in the next 5 years on the building area or below the building area, you can use the inclinometers to give you the displacement of the soil for short term and long term stability. Using the initial data input or parameter on at the early stage of construction, you can use as a predictions. So the predictions by having some sort of data set collected through the inclinometers, and then by using a proper equation and theoretical, you can calculate for the future settlement. So it means that on our construction project, during our construction project, in any infrastructures applications, uh, you cannot skip or you cannot avoid any instrumentations and controlling techniques, because it's very important, as I said earlier, for monitoring, of course, and also for the future predictions. The future predictions, as I said, that as we do not know what will happen in the few years ahead, so we can use the present data to calculate for the future expectations or for the future results or for the future output by using the preliminary or using the present data. So the present data will give you some idea what will happen on the geotechnical infrastructure. Are you having a very short, what we call it, displacement, or you may have some sort of very huge displacement? So how are you going to tackle if you have some sort of the huge displacement or big massive deformations? So at this time, you can propose by having a proper monitoring. So the proper monitoring, maybe we can install for a long period of time, and then we can install for periodically period, purposely for maintenance activity or maintenance work. And the next type of the instruments by using tilt meters. On the inclinometer, for example, here, you can see on the right figure here, this is the operator install a sensor into a probe. So the sensor will place in place and also will be located at the site area. And if you go in details, the set of the inclinometers having a cable and also cable reel and also a data collection readout. So with the manual inclinometer readings, the probe is put into an installed semi-rigid casing behind an excavation support system, and the readings are taken at a specific interval vertically behind the wall or within the slope. So these readings of tilt are then compared with initial readings, and a profile graph of lateral displacement can be produced. So somehow the sensor inside this probe may may corrupt due to the surrounding or due to the environment's effect. So if this happened, we couldn't get a lateral displacement, and then you have to come back again and take it out the sensor and place in again into this probe. And you know that if you are constraining in terms of the time, so it will give you some what we call it a tedious work lah. But we have to stand by in order to get this monitoring data. And the next on tilt meters. What is a tilt meters? It's similar to the inclinometer, but we can see how it is changed in the directions. For example, for the tilt meters are affixed to the structures and used to measure the tilt of the wall or other structural member, which can then be graphically plotted and compared with the baseline initially and then compared again with the project-specific movement criteria. So this is quite similar. Of course, once you place a structure on top of soil, uh, there is a soil movement below the structure. Similarly, the structure will also move, but not in a large movement. So you can see that initially you place a structure that is deformations on soil, also the movement of the building and the tilted building, is it move as what you expected or beyond your expectations. If you have the tilts or the structure movement beyond your expectations, so you can do a preventive prevention controlling to tackle the issue. So now the importance of these two equipments or tools are giving you some sort of the observations what's going to happen during the application or during the construction and for the future predictions. Or this also data can be in help to do some maintenance works. So the maintenance operations can be rely on this initial data collections. So the next one will be on piezometers. So piezometers purposely to monitor or the use of this piezometer for variety of the construction applications. It is include of large soil field site, excavation with slurry walls to monitor the performance of the slurry against water intrusions, dam construction to monitor the performance of the dam against sweep and the water level changes with dewatering operations. Mostly the piezometer used to collect the water level. So these are differences on the locations of this application. For example, if you remember again from the beginning, we have the positional system, and next we have seen on the inclinometer as well, the tilt meter. Now we go to the piezometer. So if the question asks you, you may expect the rise of the water level. So what will be the best equipment or tool can be used to monitor the increasing of the water level? So by using the piezometers. So the piezometers consist of small cylindrical tube with a diaphragm and electrical measurement devices within the rest of the body of the device. So when inserted into a water level pipe or grouted in place in slurry soil, these devices measure water levels or pore water pressures. So the amount of pore water pressure, for instance, can then be compared to the initial pore water pressures to understand the changing subsurface conditions and effective stresses. So on the right side of this slide, you can see how the installation of the piezometer here, and then what are the sub tools or equipment comprises of this piezometer set. So what we may expect at the end of these instrumentations or controlling for having the groundwater level. The effect of the groundwater level is the changes on the effective stresses. I mean that if you remember, when you calculate the total strength of the soil, for example, we can calculate in total stress, we also can calculate in the effective stress. So the changes of the stresses from total stress to the effective stress by having the effect of the pore water pressure. So talking about the pore pressure, When you analyze for slope stability, we also can adopt it in advanced theoretical that we call unsaturated theory. In the unsaturated theory, it's not we only have water for pressure, we also have air for pressure, but they're more complicated. But here, the piezometer can give you a water level rises that can be affected on the calculation of effective stresses. So this is also can be seen when you are estimated for vertical displacement below the embankment. If you are constructed a road construction that we have a trial embankment, so the trial embankment must be installed together with the piezometers and also the inclinometers. So the purpose of we have this one because it can give you some idea what may or what we may expect the failures of the infrastructure. So is it we have a massive failures, collapse, or we have some small of deformations? So anything that are related to the geotechnical applications, for example, deformation and stability, not to forget having this kind of the techniques for monitoring and for also controlling by using the proper instruments. And the next one, vibration monitors. The vibration monitors are typically used in measuring construction-related vibrations in adjacent buildings or other on critical elements to minimize the effect of these vibrations. So the typical use cases include monitoring of adjacent structures during adjacent demolition, pile driving, general construction related vibrations, or rock blasting. So remember, if I'm not mistaken, during the pile installation, we also install some kinds of the instruments. So these instruments, as I said, it can be adapted by having some kind of the wave measurement or the seismic measurement. If you are related to the vibrations or any kind of the uh, changes in terms of the effect of the sound or hertz. So the vibrations monitor or can be presented in the seismic condition or the seismic graph. It consists of geophone connected to a small data collecting readout. So the devices record vibrations over a set period each day and can be programmed to provide email alerts and record vibration exceeding a project specific threshold limit. So this is quite advanced because the integrations of the internet and also the data set instrument can have at the real time data. So we can estimate, for example, some sort of the failures, geotechnical failures such as earthquake. There is no early sign. For example, if you have the early sign of this earthquake, we can have the minimal impact from the seismic activities. So not all the seismic activity or earthquake predicted correctly. So somehow it can give you the alerts information through the data reading. Meaning that right now we can install any kind of the instrumentation to give some kind of idea what we may expect by having this kind of the vibrations. Remember, let's say we want to forecast weather. So it shows you the data spotted area where the zone for having rainy, where is the zone that having cloudy area, or where is the zone indicate to you a sunny day. So it's similar to these vibration monitors. It helps you to give some sort of the data predictions and alerts information to every kind of movement or vibration detected so that we can have some mitigation words to overcome any future or excessive failures. So this is one example for instrumentations and application in slope monitoring. So if you can see, there are three figures on the right side. The first one, the instrumentations being installed on the slope surface. So the what we call it, the length or the distance, the installations of the instruments that can be catered along the slip circle. And here, similarly, at the middle figure, indicating to you where the instrument being installed deeper below the slip circle. And what is the purpose of using the inclometer devices? It's again to monitor and measure the deformation of the subsurface. So it's already introduced in 1950s to evaluate the performance of natural slope, embankments, and retaining walls, providing significant data about in situ ground movement that can be an indicator of potential failures. So the inclinometers were initially utilized to monitor landslide, deformations, and assess slope instability. They are currently used to evaluate more complex interactions, such as the effect of excavations on nearby structures, deformations of building, and settlement of embankments and roadways. So these are the objective, the installations of the slope inclinometers that serve on determine whether they are isolated or extensive deformation patterns within the slope, derive whether the deformations are accelerating, decelerating, or develop at a steady rate, check that the deformations are within the limits established for the project during the design, and verify the stability of a slope or give a warning about a potential failure. So as you can see, all these objectives for the installation purpose are trying to focus on highlight the data set collections on the preliminary constructions, during the construction, and also post-construction. Post-constructions is more on the monitoring and controlling potential failure. During constructions is we try to prevent or we try to estimate or predict the deformation or any kind of the movement in our range of design and analysis. Okay, let me share to you one video. Okay, on the slope monitoring. Okay, that's end for the video sharing just now. So let us recap what we have learned throughout the beginning of the chapter 3 sehinggalah instrumentation and controlling. Okay, kalau ikutkan this week kita dah masuk juga dengan chapter 4 sebab if we check on the lesson plan, so there will be a week that we are not covering any kind of the topic. If I'm not mistaken, is the week 13. So that is the purpose where you may deliver all your project, group project task assessment, and the project must be presented during the class sessions. So I try to finish the remaining chapter 4 within the period of the weeks given here. So for your information also, next week we're going to touch in new chapter 4, and also those who have not finished yet on learning activities from week 6 to week 9, please take your time during our class session, remaining class now or from the past time yang you tak siap lagi tu, tolong siapkan project ataupun a mini project regarding on the forensic engineering or case failure selected. So it's good if you can start off your slide or your video presentation by introducing your name, or on the slide already shown your name and then the course code, what is your title of the case or the title of the project selected, mini project selected. Okay, who can explain what we have watched from the video just now? So it is an extensometer. Is it similar to the inclinometer or any kind of other instruments as I explained just now? Siapa boleh share daripada video tu apa yang you dapat? Sebab kalau you tengok tadi kan, the instrumentations ni, a good things about technology currently, they can give to you very fast data collections. So it's not backdated data, where the data is very important for us to take any action or to predict any risk failure, or we can do risk assessment. So from the slide is from the video that you have watched just now, it shows to you that the data logger presenting the graph visualizations on real-time collections, where you can see that at the early stage of installation, where there is no at all for measurements, once after period of time and with some sort of the weathering changes from the sunny to rainy day, and the tool or the equipment extensometer collect the informations on the site. And also it also can store the informations regarding to the design and analysis or the limitations of the